Okay, well, let's get underway. So good morning, everybody, and welcome to the session on realizing the benefits of upgrading Microsoft SQL Server. So let's get underway with the presentation. My name is Victor Isikoff. I'm not going to talk too much about myself. I don't blog, although I want to. The website doesn't have anything interesting. If you have any questions, that's what I'd be encouraging you to do. Send me an email, possibly go through LinkedIn. Don't do anything with Twitter. Sort of promising to do that next year, but we'll see how we go. But certainly if you have any questions about the presentation, SQL Server in general, please feel free to send me an email. So let's talk a little bit about this particular session. So I do a lot of SQL Server upgrades in the field, optimizing sort of hardcore OLTP environments, designing high availability solutions, etc. And what I see out in the field is that you sort of go on a customer site and you're doing a SQL Server health check or review or whatever the case is, and you can sort of see they're running on 2012, but you can sort of see, oh, this database was developed on 2000, and then they upgraded to 2008, and then maybe jumped to 2012, but they haven't enabled any of the new functionality inside SQL Server. So they're not getting the full benefit of upgrading. So they're sort of doing it because they might be on an EA agreement, software assurance, or we need to upgrade because Microsoft stopped standard support on the product. But that's not a really good business case for upgrading in a way there. So you're not really getting a good return on investment for that. So this particular session is trying to be very, very practical where you're upgrading to SQL Server, but you can also take advantage of some of the functionality transparently even to optimize performance, reduce licensing cost, consolidation, virtualization, etc. So you can really have a lot of wins in this particular space. So this is what this particular talk is trying to do. So make your environment a little bit, more resilient, more agile, more performant, etc., etc., etc. Because I think the way that we've been managing and administering SQL Server in the last 10 years is not the way to do it going forward the next 10 years, okay? With the way Microsoft's releasing the product, developing that product, people are always saying, oh, we're not going to upgrade to SQL Server until Microsoft release Service Pack 1 because they're scared of what's happened in the past or perceived what's happened in the past. But Microsoft's developing 2016 and implementing 2016 in the cloud right now. So it's been running in the cloud for X number of months probably. There's millions of databases using 2016. So there's very, very little risk, I think, of upgrading to the latest version and certainly having that mentality of don't upgrade until a Service Pack 1 gets released. So it's a brave new world that we have with SQL. So I think the old ways of doing things no longer apply for SQL. Anyway, just a couple of thoughts there. So as you can see, this is sort of the motivation rationale for the talk, if you like, there. So you seem to see that everybody's stuck in this business as usual mentality. So don't touch it if it's not broken. Let's not do innovation. And I was around in the 90s doing stuff in SQL Server 6.5. And people would be excited about SQL Server 7 and some of the features introduced in it and taking advantage of it and then getting better performance, getting 20% transactions, throughput, revenue, whatever the case might be. Whereas now I tend to see the industry is just doing more shift and lifts. So we're just upgrading like for like. We're not changing anything. And sometimes with some of the things that I'll show you, you can make some very small changes that will have a massive impact on the business. And it's completely transparent potentially to the application. So there's nothing that you need to change. Just do something at the database engine level. You'll have reports running from 2.5 hours to under half an hour. And that could transform the business. You maybe had to archive data at the end of each year because you had such a large volume of data. Now you don't have to for the next 10 years, etc. So I've got some little examples and some use cases of where you'll see these sorts of things. But as I said, this is what I'm seeing in the industry itself there. And again, you see that people don't tend to know what's in the different versions of SQL Server. So they can't really take advantage of that. And I don't know if that's a messaging problem by Microsoft in the industry or an education problem. Again, so these sort of Groundhog Day databases stuck doing the same thing day in, day out, and nothing's changed since we initially deployed the solution in earlier versions of SQL Server. And as I said, at the end of the day, organizations aren't getting a value on their investment in SQL, in their enterprise edition licenses or in enterprise agreements, storage costs can really blow out in certain cases because everybody's databases are just getting larger. They're not taking advantage of some of the compression technology, which can have phenomenal wins potentially for you. So it applies across the board then, and that sort of bleeds into maybe backup times taking too long. Maintenance windows are starting to take too long and so forth there. So there's lots of opportunity to optimize the environment quite simply, and then of course there's stuff that will take a little bit more work testing those sorts of things there. So in a way what I'm trying to do is change the conversation with the business, start to define business goals and business benefits as opposed to worrying about technology and features, if you like, of SQL Server itself. So this is sort of the agenda for what we'll be discussing. So talk a little bit about current state. We've already started that particular process. And then as you can see, we're just going to go through the upgrade process, talk about some database engine configuration options, and then manageability, high availability, etc. So again, don't forget that with SQL Server, Microsoft are always concerned about backward compatibility. So for example, with certain database engine options, the SP_configure options, they're there with the same default value that existed in SQL Server 7. And they don't want to change it because Microsoft are always concerned about backward compatibility. So there's a whole bunch of database engine configuration options that you should probably change automatically when you deploy a new instance of SQL Server because they're going to benefit you in a number of different ways. And the interesting thing is, and I'll discuss this in more detail later on, that's what Microsoft are doing in 2016. So how many people here have downloaded and sort of installed, played around with 2016? Okay, so a few people. So you'll notice that when you install 2016, there's a few more options on how to configure TempDB and other things like that as well. So there's a whole bunch of stuff which will be enabled, which is not really backward compatible, which is interesting. So Microsoft is sort of changing direction a little bit with that and sort of being a bit more aggressively forcing you down a particular path, if you like this. So we'll discuss that in more detail when we look at the database engine configuration options themselves there. So let's talk a little bit about current state and some observations about what I see in the industry. So again, people are a little bit afraid of the frequency of which SQL Server is being released, I think. So again, back in the day in 2000, 2005, people said it was too long for them to release SQL Server between releases. And now people are scared that SQL Server is being released every so often. But, from my dealings with Microsoft, my understanding of Microsoft, for the last, let's say, 3, 4, 5 years, what have Microsoft been doing? What they've been doing for the last year is building up their cloud platform. So then some of the developers that have been working traditionally on SQL Server features have not been working on new SQL Server functionality. They've sort of been laying down the framework with Azure, SQL DB, then SQL W, etc., etc., etc. So now that they've sort of fully baked that and that's come good, if you like, now they're starting to turn into the more innovative side, R&D inside SQL Server. So you're going to see a lot more features, I think, being released in SQL Server and the frequency of SQL Server possibly being released a little bit more. I think with SQL Server 2014, how many people, let's say out of an org of 1,000, worked on SQL Server 2014? Anybody want to hazard a guess as a percentage? Yeah? 10%, 100 people out of 1,000 were working on new features in SQL Server 2014. The rest of the org is working on cloud. Now that they've done that, they're now turning their focus now on SQL Server Engine. So again, you're going to see SQL Server being released every 18 to 24 months. In SQL Azure, that's actually not right. They're not updating every 4 months. They're updating a lot more frequently on demand with that. And that's the interesting thing, because if you were around with SQL Server quite a long time ago, you would have known that we would have had something like an Alpha 1, Alpha 2, then a Beta, then a Beta 2, then a Beta 3, then Release Candidate 1, then Release Candidate 2, then RTM, or Gold, and then RTM, and so forth. Whereas now what Microsoft are doing is developing new features in Azure. And as they become mature, people are testing them, they're happy, they're being put into the boxed version of the product itself there. So as I said, expect a lot more features, expect a high frequency of SQL Server being released, and expect a lot better stability of the releases, so you shouldn't be as concerned about upgrading SQL Server because it's been well and truly tested for the last X number of months in Azure with the way they're rolling out the product, if you like, there. And as I said, the industry is still managing SQL Server as if it was the 90s there. So again, everybody's risk averse. We don't want to touch anything. We don't want to upgrade from 2008 to 2012, even though all the new features in 2012 don't impact your database solution. So your core database solution that does inserts, updates, deletes, and selects, that's not going to change between 2008 and 2012, most likely, okay? So again, we sort of, I think, need to be a little bit more agile. But at the end of the day, I think we also need to think about how we're currently managing our SQL Server infrastructure and starting to change that conversation and that process as well. So think more about change management, release management, incident management, etc. Because again, if you're a large organization, you're a large bank or something, whenever people start talking about SQL Server upgrades, people just get horrified because we have 500 instances of SQL Server. We don't know who owns the databases, who's the business owner, who's the system owner, we don't know who the vendor is, etc., etc. What users log into the environment. So possibly start to build systems which keep track of that sort of thing so that when you need to next upgrade SQL Server, you can do it much more rapidly and take advantage of the new functionality, etc., that we're talking about there. Down the bottom, initially some of you said that you're still on SQL Server 2005, so notice that in April 2016, support for SQL Server 2005 ends. So that's end of extended support now. Okay, so something to keep in mind. So I'm not going to spend too much time here because I'm sure you can fill me with all sorts of stories of what's the upgrade blockers inside your particular organization. So again, very, very common for you not being able to upgrade a database because of vendor support, so the vendor's disappeared or we don't support the latest version of SQL Server, you're paying a maintenance support agreement on 2005, it's not in their interest to allow you to go to 2014 because they've sort of already got your money in any case there. So again, possibly learn from mistakes in the past. I was dealing with a very big power company in New South Wales and talking to the CXO, and I said, I don't understand why people don't ask when you potentially buy a vendor solution, will you support the next version of SQL Server when it gets released within 90 days or something like that? And he's like, oh wow, what a brilliant idea. And I thought, like, are you kidding me? You don't have to be a genius to work something like that out. But people aren't asking that question when they're looking at procurement and looking at vendor solutions. They're not asking these types of questions there. Again, a big upgrade blocker is the risk or perceived risk of, database/code will break after a SQL Server release. And again, there's tools that help you mitigate that with the Upgrade Advisor and a few other things. But again, the more you know about your environment, you're starting to lessen that particular risk, if you like, there. For me, the problem is always unknown risk because people don't document their solutions. So their database, is connected via link server to an Excel spreadsheet or has some DLL installed that's part of a comp component that's registered via SQL Server. So it's always these external dependencies, I think, in large organizations and old organizations, old database solutions, which to me represent more of a risk there. And again, that's very hard to detect. So the benefit there, what you should be doing is starting to document these things. So when you do a next upgrade to SQL Server, take that as an opportunity of getting the shop into order so that when you start to go forward from, let's say, 2014 or 2016, you won't have to go through this pain again. So start your change management, release management, documentation, dependencies, etc., so that you don't have to go through this again and you can take advantage of the hard work that you've done there. A lot of risk out there is perceived risk. So as I said, people are scared about things changing. And again, if you're a bank, you probably are very risk averse. So you might have to go through 3-6 months worth of testing. Whereas some organizations just upgrade and have no problems whatsoever. So again, it's up to you. It's not the luck of the draw, but there's things that you can do that can make you more agile with this. And as I said, if it's taking you 10 months to do upgrades of your SQL fleet and Microsoft's releasing something every 18 months to 2 years, you fundamentally have a problem there somewhere. So you're going to have to change something somehow to make it a lot more agile, if you like, there. Of course, everybody's running lean IT these days, so lack of resources, be they IT pro developers, domain level knowledge. The guy who wrote this database has since left, etc. So again, that's what you see out there. And as I said, there are plenty of tools that can help you analyze your current state, although of course they're not going to be 100% foolproof. So here are some caveats that I sort of again see. So these are sort of mistakes that people make in the industry, if you like. With some examples. So just things to be aware of. So applying previous knowledge or experience. So again, you might have experience with SQL Server etc., for the last decade. And just be careful of sometimes applying that knowledge in the later versions of SQL Server. Classic example for a government organization was clustering. So they set up a brand new SQL Server cluster on 2014, absolutely customized, set up perfectly, except for what? It was set up completely incorrectly for Windows Server 2012. So they set it up perfectly for 2008 R2 backwards using all of their knowledge, but the best practices for Windows Server 2008 clustering are now completely different, and in fact the opposite for 2012. So don't make the mistake of sometimes applying this knowledge, not knowing or realizing that that old knowledge applies to, let's say, 2008 R2 backwards and not to the newer versions of Windows in this particular case. And the same applies to SQL Server. The other mistake I see as well is people automatically taking advantage of new features. So I cannot count the number of times I'm in a boardroom meeting and some solution architect says, we should use availability groups. So, or we should, basically availability groups is a good example. So they think that because there's a new feature in the product, it must be better than the old feature in the product, which was failover clustering. And that is completely and utterly wrong. So you need to understand the technology, you need to understand your business requirements. So again, it's still valid for you to use clustering over availability groups, depending on your database solution, your processes, your organizational maturity, those sorts of things like that. So don't get stuck in that particular trap there. Or again, with failover clustering, people automatically use the file share witness even though they could use a disk witness or majority node set. And they don't realize that you potentially have slower failover and the cluster might not be able to come up in certain scenarios if you use a file share witness. So again, you should be using a file share witness as a preference last, as opposed to people saying, this is a great new feature, let's use file share witness. So again, you need to understand the technology. And again, as I said, this sort of what I call BALF, business as usual forever. So let's not change anything, let's not do anything, we just do a shift and lift every time we need to upgrade SQL Server. So we get stuck in this mentality. And as IT people, it's up to us to change the conversation with the business, engage the business and say, look, if we upgrade and take advantage of these features, think tactically, think strategically, we can maybe get 20% increase in revenue, reduce storage costs by 40%. So turn the conversation around into business benefits, and then hopefully the sponsorship for these projects will be better and you can take advantage of SQL, everybody wins there. And the other thing I want to point out is that, again, technology itself hardly ever delivers. So people think, I'm going to upgrade from SQL Server 2005 to 2014, I'll automatically get an improvement in performance. And invariably, that is not the case. And it's never going to be mostly hardware that's going to improve performance. So again, classic mistake. We're going to upgrade, we're going to get better performance because the hardware is better. Absolutely not. Invariably, it's always about database design, the code, those sorts of things there. Last couple of months, 4 months, I had a customer where they were running on SQL Server 2005 and Windows 2003 on a machine with 100 gigs of memory and 48 cores. They went to 4 SQL servers running SQL Server 2014 on Windows 2012 R2. Each machine had 768 gigs per minute. 768 gigs, and they were using extremely fast flash. And on the old system with 100 gigs of memory and 48 cores, they were doing about 40,000 transactions per minute, 20% CPU. On the new hardware, when they upgraded initially, it was 10,000 transactions per minute, 100% CPU utilization. Database was consuming 600 gigs of memory. So again, in this particular case, it was the code that was the problem. So we spent months fixing the code and then brought down the performance to acceptable levels there because we needed to hit 40,000 plus transactions per minute. But just again, don't get stuck in that mentality of, it'll automatically be faster because we're upgrading to a new version of SQL Server. And obviously in that case, it was from 2005 to 2014, so lots of changes between releases. So let's talk a little bit about the upgrade process. So as I said, I'm not going to talk about the mechanics of using the upgrade advisor or doing X, Y, Z, etc. Just wanted to talk a little bit at a high level of what you should be doing and viewing inside an upgrade project there. And for me, an upgrade project is definitely an opportunity for yourselves. So you can definitely get better performance, reduce licensing cost, and basically win all round. So again, I've customers down in Melbourne where their licensing footprint, sort of VMs grew all over the place organically, and they had a per annum cost of, I think, over $250,000 per annum on SQL Server Enterprise Edition licensing. And sort of we went through the exercise of looking at their SQL Server fleet, doing a bit of analysis of performance and those sorts of things, and they could potentially reduce their licensing cost for SQL Server from $60,000 to $90,000. So that's a massive saving. And then with that saving, you can invest in some really good hardware as well. So you can get better performance, reduce storage, and reduce licensing costs. Okay, you just need to do the work, but it definitely is possible there. It's a great opportunity for you to optimize, consolidate, virtualize, learn from the mistakes that have passed there. So we used to deploy SQL Server in this way. That hasn't worked out too well, or there's new functionality that we can take advantage of. So learn from the mistakes of the past, do things differently as opposed to this lift and shift mentality. Something that I would be highly recommending you do, and what we try to do inside upgrade projects, is start to develop a standard operating environment. And again, if some organizations are used to doing this, but again, all organizations should be looking at developing a standard operating environment for both Windows and SQL Server. And that's definitely going to help you if you're doing virtualization as well, with the way hypervisors work, with those sorts of things like that there. But start to develop an SOE for Windows. So look at your disk layout in particular. Storage is always important for SQL Server. And the other thing that I don't see being used a lot of, but that I would highly recommend, is to use Windows Server Core. So if you reduce the footprint, the size of the operating system, hopefully there's less patching, hopefully it runs quicker, there's less vulnerability, and you can have higher density in the virtualization space as well there. But the more you have a standard build for Windows and SQL, it makes it easier for you to administer, makes it easier for you to troubleshoot, those sorts of things there. The other thing that I'd be encouraging you to have a look at, depending on the size of your organization, is start to define tiers. So the idea here is, again, it completely depends upon your organization, but have different tiers, if you like, of SQL Server that represent different importance, if you like, to your particular organization there. So the idea here is you define a number of tiers for your organization. We'll have a little proof of concept on the next slide there. So again, for most organizations, 3 tiers are sufficient. For some, it's even less. So anyway, so consider future growth. Also consider Azure, because what you might like to do is map the tiers to Azure so that you know that the different machines available in Azure have different memory, processors, storage, etc. configurations. So you could potentially map your tiers into Azure. So the idea here is if management tomorrow says, oh, we want you to move this particular database solution to Azure because of whatever reasons, you can easily move that database solution, that SQL Server instance, to the appropriate tier inside Azure, if you like. So something to think about there potentially there. But the idea here is you define the different tiers which are going to have different hardware configuration effectively, and then you start to define the service levels for those particular tiers there. So again, time to engage the business and put particular databases into particular tiers. Because the problem is if you have 500 SQL Server instances with all the databases and everything crashes or you need to reboot, which ones do you focus on? Which ones are more important to the business and so forth there? So the idea behind tiering is that you put the databases into a specific tier because of its importance to the business, its high availability requirements, whatever you define, and that then allows you to focus on which machines to get up and running first, which machines are more important to troubleshoot versus not, which are dev, which are UAT versus prod environments, those sorts of things there. So the idea, as I said, define your tiers, engage the business, and then you basically start to map the applications to the appropriate tiers. And I've got a proof of concept over here, as you can see. So the idea in this particular case, we might have, as you can see, 3 tiers, tier 1, tier 2, and tier 3. Then you can have a look at the hardware, and as you can see, we've got some different standards for setting up the different tiers. So in tier 1, we have separate LUNs for the data and the log, and possibly, again, these are the more performant databases, so we want to have separate LUNs for temp DBs, data, and log as well. If we look at tier 2, we don't do that, okay? So we just have separate LUNs for data and log. For tier 3, we don't bother about that. So we might have everything on the one LUN in this particular case. And then you can see for each particular tier, we've got different hardware profiles. So tier 1A has 8 vCPUs, 128 gigs of memory, and we use availability groups. Tier 1B, 4 vCPUs, 64 gigs and clustering. This is just an arbitrary example there. So the idea here is then we start to have various applications inside our business, and we engage the business, we understand the high availability requirements, we might understand the IOPS requirements, etc., 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 and then we can start to map our line of business application to tier 1A, our GIS application to tier 1A as well, SharePoint BizTalk on tier 1B. Etc., etc. So this is what I'm sort of encouraging and working with organizations to deliver. So you're thinking more of databases as a service that you provide to the business. So then you need to meet a certain profile for performance, for availability, possibly security. So you might have one particular tier which has to use TDE, which has to use different encryption, whatever the case might be. So that's where all the secure applications reside. But it makes it easier for you to, as I said, maintain this environment. So the idea here is, you know, if we have to reboot all of our hypervisor hosts, we know that we need to bring up the tier 1A environment first. After that's stabilized, we bring up tier 2. Tier 3 might be for UAT, dev, whatever the case might be, so we don't care about that one. But you avoid the boot storm in that particular case. So as I said, think about doing something like that in your next upgrade project to make it easier to administer, troubleshoot SQL Server. Again, a lot of people do this, but a lot of people don't. So think about having different environments. So again, you've got your prod environment, you have some user acceptance and testing environment, and you have a development environment. Some people have staging, some people have pre-prod. So again, it can be a lot more complicated than this, but have different environments. Something a lot of people don't realize is that you can use Developer Edition for this. So people seem to want to use MSDN licenses, but how much do you pay for an MSDN license? $3 grand, $4 grand, something along those lines. How much is the Developer Edition of SQL Server? It's about $100 per user. So you license all of your developers and testers with Developer Edition, and then you can install as many Developer Editions of SQL Server inside your UAT and dev environment. You can still buy the MSDN licenses and people can take advantage of Visual Studio and whatever else they need to do. But again, I see a lot of organizations not taking advantage of Developer Edition for their UAT and dev environment, which can be a substantial saving with licensing as well there. And the other thing, obviously, that some organizations are doing is using Azure for your UAT and dev environment. So again, spin up VMs, spin up the application tier, do your load testing, shut it down. That can be very, very cost effective as well. Okay, so think about possibly doing that as well. Okay, so let's talk a little bit about SQL Server features and what you might be able to take advantage of. So this particular slide is just showing a little bit of a timeline. And this is sort of to dispel myths, because a lot of people think, oh, Microsoft's more aggressively releasing SQL Server. And if you look at it, and again, depending how old you are, you might remember there was a big gap between 2000 and 2005 for a number of reasons. But you can see that sort of after SQL Server 2008, we've been pretty consistent with how often we've been releasing SQL Server. So you can see, again, it's been about 2 years, maybe a little bit more, maybe a little bit less there. So expect this to be a minimum, if you like, there. Okay, so you might get it a little bit more aggressively. Again, I can't say too much. But the idea here is expect something every 18 months to 24 months going forward. I don't think Microsoft's officially announced when 2016's going to be released, have they? Okay, all right. Summer of, well, yeah, no, absolutely. US summer of 2016.
No, I'm not saying from that. That's what I heard when I was...
Okay, yeah, sure, okay. All right. Well, I can't say certain things on the microphone, so you can always talk to me after that. But the idea here is around summer of the US, okay? So, again, expect that being released sometime next year in, let's say, first half of the year. Okay, so again, expect this, as I said, going forward. Okay, so what I've done over the next couple of slides is just showing you what features were introduced in what versions of SQL Server. If you go to the very, very end of the slide deck, I have a massive set of matrices on what's the difference between 2014 and 2005, 2014, 2008, 2014, 2014, 2008 R2. So again, if you need to go to management or you're going through an upgrade project there, you can have a look at that and see here are the deltas between what we're upgrading from to what we're upgrading to. So again, you can think about what features you might want to take advantage of in that version of SQL Server being upgraded. So again, these are the big ticket items, but there's certainly a lot more inside the products themselves there. And I will have some examples of where we've turned on compression and we've got a massive saving in performance or potentially storage. So again, just showing you the big ticket items and later on discussing them in more detail and how you can use them inside your organization. And some of these things are going to give you transparent benefits. So you don't need to change SQL Server code. You don't need to do anything. You do something at the database engine level and you can reduce query time. You can reduce your storage, whatever the case might be. So something definitely that I don't see being utilized a lot of is compression. So again, a lot of people think that compression is something like a zip algorithm. So we sort of compress data on the fly as we read and select the data, and that's not quite the case. It's more a form of deduplication. So it's not as if we pass the data through a compression algorithm and that's how we compress databases. What we basically do with compression is store the data more optimally. So the idea here is if you compress the data from 100 gig to 10 gig and it's on disk at 10 gig, when you read it into memory, it still takes up 10 gig. It doesn't take up 100 gig. So it doesn't decompress from disk and in memory take up 100 gig, which means that before with your VM running in whatever, if you wanted to scan that table, which is 100 gig, that would not give you good performance because your VM doesn't have enough memory to cache all of that. Whereas if it's now 10 gigs in size, maybe your VM has 64 gigs. So you can cache that entire table that used to be 100 gig now in your VM with 64 gig because that data is only 10 gigabytes in size. So it can be very, 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 very quick for you to take advantage of this compression and get phenomenal improvements in performance. You do pay a little bit of a cost when you compress, but when you're reading the data, it should generally be fine. So again, what's your application like? Is it 95% reads, 5% writes? So again, knowing those sorts of things is going to help you. Backup compression was added in SQL Server 2008, and I just wanted to point out that Microsoft pushed it into the standard edition for 2008 R2. So again, take advantage of that, reduce your storage costs for backups themselves there. So again, you'll see a couple of other things with extended events, file stream, and the new date and time data type, which generally tend to be underused as well. If we go to SQL Server 2012, you can see the big ticket items were fundamentally availability groups. So again, I think of availability groups as an evolution of database mirroring. And we'll talk a little bit more about availability groups, and availability groups are a fantastic, phenomenal technology, but you need to know what they're used for. So in certain scenarios, they absolutely shine. If you're implementing availability groups with something like SharePoint, I'd be a little bit nervous. SharePoint's quite complex, multi-database environment, all databases have to be in full recovery model. It's getting a little bit ugly to implement that on an availability group. I'm not saying don't do that, but make sure you understand how availability groups work. I did a session at the past summit just on SQL in Seattle a few weeks ago, and just again talked about the use case, how to optimize, how to administer availability groups correctly. And I also talk about organizational maturity. So we've implemented some we were potentially going to implement some availability groups for some government organizations in New South Wales, and they didn't have a mature DBA team. So we said, look, it's really hard to maintain availability groups. It's easier to maintain clustering. So we chose clustering over availability groups fundamentally because of the organizational maturity with DBAs managing SQL Server, being new to SQL Server in that particular case there. So again, the business requirements trump the performance or technical requirements, if you like, there. So availability groups have a number of benefits with multiple replicas that you can read, you can report off, etc. And I'll talk about that in more detail later on. But fundamentally, as I said, the big ticket item for SQL Server 2012, but just make sure you understand the technology and how to administer it to make sure that you get the best of it. Another big feature that was released in SQL Server 2012 is column store indexes. Now, they really shine in 2014, so I won't talk about them here. But again, this was a column level based indexing structure or table structure that was initially introduced in SQL Server 2012. The problem with column store indexes in SQL Server 2012 is that they were read-only. So you couldn't update the table that had the column store indexes, and there were only effectively non-clustered column store indexes. And you can see that in the next release of SQL Server in 2014, those limitations have been taken away there. So you can see clustered column store indexes have been added. So again, that's the big improvement. And I think I have a mistake in that particular slide. So that should actually say clustered column store indexes, they're updatable, so that's been improved. And we also have something called buffer pool extensions, and that's available in all versions of SQL Server. Okay, so that buffer pool extensions should be a bigger slide bullet point, if you like, there. Notice we've also enhanced availability groups. So we've increased the number of replicas to 4 to 8. But the other thing that Microsoft did as a result of feedback from customers in SQL Server 2012, if something was wrong with your primary replica, your 2012 couldn't be accessed. So they've sort of decoupled that, okay, the secondary readables, okay? So the idea here is you can still access the readable secondaries if the primary is offline, which wasn't the case with SQL Server 2012. So that's the big other improvement with availability groups. The really big feature in SQL Server 2014, which has had a very poor uptake, unfortunately, is in-memory OLTP. Okay, so in 2014, you have the capability of putting tables into memory. There's no locking, there's no latching going on. They don't reside on disk. So you're going to get an improvement in performance as a result of that. Not so much the fact that they're in memory, because if you have enough memory, you can always cache the entire table. So people mistakenly think, oh, we're going to have improved performance because it's in memory. But your data that you're working with is always in memory. So they all only reside in memory, but you get a performance benefit because there's no latching and no locking going on. So there's no contention effectively. So things don't have to wait for something else to complete with readers blocking writers, etc., because latch-free, lock-free. The big gain that you will get within memory OLTP, which might potentially give you up to a 30x improvement in performance, is if you start to compile stored procedures into native stored procedures. So you now have the capability of compiling stored procedures into C code. So the idea here is that's where you get the full benefit of performance. So if you just take advantage of in-memory tables by themselves, you might get a 7x improvement in performance. If you now compile your stored procedures into native stored procedures, you might get the 30x improvement in performance there. Okay? And, sorry, yes, question?
Does it still follow all the ACID principles?
It follows all the ACID principles, but you also have the option of it not following the ACID principles and durability in particular. Because what you have the capability of doing within memory OLTP tables is saying some tables are non-durable. So when the system gets rebooted, fails over or crashes, that table is lost. But that's perfect for things like a staging table for ETL or other business cases where you don't care if the data's lost. So they've given you that option as well. Okay? And again, if you go to 2014, you can take advantage of in-memory tables for your table variables or temp tables. So in some organizations, I've seen code patterns where they heavily use temp tables and table variables, and tempDB becomes the bottleneck. Okay? Massive bottleneck. So what you could potentially do is not move your database user tables into in-memory OLTP, but you could potentially move just the stored procedures table variables and temp tables, migrate them to in-memory OLTP tables and get some performance benefits there. But otherwise, your database and your code remains the same as before. Okay? We also have something called delayed durability, which applies to availability groups, and I'll talk a little bit more about that later on. Okay, so let's talk a little bit about some database engine configuration issues. So what we're talking about here is, as I said, when you now install SQL Server 2014, you've got all these default settings for these configuration parameters. They might have been relevant back in 95 or 2000, but these days, you would probably be recommended to change them to something other than the default, okay? And Microsoft are addressing some of this potentially in the next version of SQL Server. So let's have a little bit of a look at the database engine. So again, I have a number of customers who never upgraded from SQL Server 2008 simply for the fact that in 2008 R2, Microsoft introduced a limit of 64 gigabytes per SQL Server instance for standard edition there. So for them, they're running on 2008. The problem is that their database is quite happily consuming 100 gigs of memory or whatever. So if they upgrade to 2012 or 2008 R2, they're going to get potentially worse performance. The good thing, as you can see with SQL Server 2014 being released, the standard edition now supports 128 gigabytes of memory. So again, that could potentially be a completely transparent benefit. Upgrade from 2008 R2 or 2012, standard edition to 2014, you can fit more in the buffer pool, larger procedure cache, etc. So you're going to get improvements in performance there. The other thing that I wanted to point out, and I've already mentioned earlier on, is try to take advantage of Windows Server Core. So again, you don't have the GUI, you don't have all, i.e. all of that excess inside Windows. It's just a small footprint of Windows Server. Basically, you know, the kernel, the drivers, sort of a command prompt management, you can install SQL Server on top of that there. So again, much smaller memory footprint. I think it's like 4 gigs or something like that as opposed to 27 gigs. Sorry, it might even be less. It's less than a gig. Sorry, I made a mistake there, I think. So again, smaller footprint, reduced surface area of attack, potentially less patching required, so you're going to meet your SLAs for availability there. And again, benefit potentially there is that you can have much higher virtualization densities in your hypervisor as well there. And as you can see, it's been supported since SQL Server 2012. Microsoft are releasing an even smaller footprint of the operating system with Nano Server, so maybe a matter of time before we see SQL Server supporting that as well. So just keep that in mind. The next thing that I just wanted to draw to your attention was buffer pool extensions. So possibly relevant to people that have a slow SAN and they want to take advantage of Flash locally. So there's a number of different use cases for this. This is available in all versions of SQL Server, so it's not an enterprise edition feature. But fundamentally, what you have the capability of doing is you basically have amount of memory that you've allocated to SQL Server. And eventually what's going to happen is those data pages are no longer required or they're being aged out, so SQL Server would normally flush them out. And then if you need that data again, we'd have to go across the fabric or across the network onto the SAN, load the data into our SQL Server instance, and it would be back in a buffer pool. What you have the capability now of doing is possibly buying some cheap flash storage and putting it locally into that particular server, and then telling SQL Server that that flash storage is an extension of your buffer pool. So what happens then is pages that are clean, so they're not dirty pages, are written to the local flash storage as opposed to them just being flushed out of memory. So if you need to have access to that data again in that table or whatever the case might be, you can go to your local flash storage instead of going across the fabric to your old SAN or whatever the case might be. So there's a number of cases in which you might want to take advantage of this, okay? You might have an old SAN that doesn't perform as well, or it's overloaded. You can't get rid of it for another couple of years because accounting purposes, those sorts of things. Management doesn't want to pay for it, whatever the case might be. So again, you can install some local flash storage, and then the idea is that we go to the local flash storage instead of going across the wire to wherever it is. You could potentially have databases up in the cloud in Azure Blob Storage. So again, your MDFs are in the cloud, but again, they get downloaded, the data gets downloaded, and then basically you could use the buffer pool potentially. So there's all sorts of interesting use cases with this potentially. Yes, question? It is a server specific thing, but when you fail over, you drain everything out of the buffer pool anyway. So it can work transparently. And the idea here is if that flash disk dies, it's not as if you need to RAID them. If it dies, then you just don't get the benefit. It's not going to bring down your whole SQL server. Okay, so again, just be aware of this because some interesting use cases of where you might want to take advantage of this technology. And you can see the benefits there with reduced I/O latency because you don't need to go across the wire, increased random I/O throughput, and so forth and so forth. And that's just a diagram I've stolen from books online. The other thing that I'd be recommending you highly do with every release of SQL Server is going through all of the database configuration options, having a look at the new ones, have a look at the default setting for everything, and decide, okay, for our standard operating environment for SQL Server, we're going to change these defaults. And this is going to be the default for our organization. So there's certainly more than this, but I just wanted to draw your attention to a couple which potentially people don't know, or potentially everybody could almost turn on, take advantage of, but by default they're turned off. That certainly applies to the first one, so optimize for ad hoc workloads. And I think there's been a discussion with Microsoft as to whether this should be turned on by default in 2016 going forward. So that's the kind of discussions Microsoft are having with external customers, people, etc. So with optimize for ad hoc workload, what you're doing is telling SQL Server not to fully cache all of that ad hoc SQL that's being generated by your middle tier web server, whatever the case is. And again, standard thing that I do with a SQL Server performance review is have a look at the memory usage. So this amount of memory is allocated to the buffer pool, how much of it is the procedure cache, how much of that procedure cache is ad hoc code. Because ideally you don't want to have a lot of memory being taken off by single use ad hoc code. So this is what this is trying to prevent, this procedure cache bloat where you're using too much of the procedure cache and thereby degrading performance because you're not caching enough data. So the more data you cache, the less need to go to disk, better performance. So this potentially is something you turn on for every SQL Server by default. Okay, that becomes a standard. The other one potentially is backup compression is turned on by default, so you can control that at the server level. You might have other database backup products there which tend to have better compression ratios, which you can control. They do tend to then use more CPU, so Microsoft tried to find that balance between good compression but not taking up too much CPU. But again, if you're not taking advantage of those particular products, turn on backup compression. So your backup sizes are going to be smaller, so save on storage cost over there. And the last one I added, because a lot of people don't know this one, so this was added a while ago back in SQL Server, so I keep forgetting what gets released in what version. But what you have the capability of doing is saying, I want to get a blocked process report effectively. So if something's being blocked for a substantial period of time, notify me. So it's very, very similar to the deadlock graphs that you can get, but because that is being used by this deadlock monitor, and this block process report is taking advantage of the deadlock monitor. So the deadlock monitor sort of monitors things, and every so often we'll see if there's a deadlock, but now you can also tell it to look at blocked processes and notify you potentially of blocked processes. Because invariably, again, people are concerned about performance, we have performance problems, and they always think it's a lack of memory, it's a lack of IOPS, it's a lack of CPU, and it's not a hardware issue. What is it? It's a contention issue. You're generating 20,000 deadlocks per hour or something like that. They did not know that at all because it's not natively exposed in SQL Server by default. So again, go through the database engine options and have a look at some of these things that you can potentially configure from a default value, which as a standard for your organization. Something that I would also be highly encouraging you to do is have a look at trace flags. So I think trace flags have always been, oh, don't touch them because they're dangerous and evil and only MVPs and MCMs can modify them. I'm sure we're all smart people here. We can read documentation and decide whether a trace flag is valid or not. So what you can do is turn on trace flags, which will change the default behavior of the engine. And there's some really good features and functionality. So the first two trace flags that I have, 1117 and 1118, is for tempDB optimization. So what I've done is I've sort of given you a brief description of that particular trace flag and then also given you the source for if you want to read that information. The interesting thing is that in SQL Server 2016, by default, trace flag 1117 and 1118 will be turned on. So that's what I'm telling customers right now. This is the future for 2016 going forward, so why not start to take advantage of these trace flags so that then when you jump from 2014 to 2016 or whatever, there's less things that are different between the old environment and the new environment, so that will help in troubleshooting. But Microsoft is saying, this is so good for the environment, for optimizing performance with tempDB activity, that we're going to turn them on by default, okay?
And 8048 as well.
Yes, yeah, there's a number of them, yes. Okay, so, have a look at those two. Earlier on I said how some organizations have performance problems and they don't realize it's a locking issue, deadlock issue, etc. So you also have trace flags which enable deadlock detection. So if you turn on 1222 or 1204, that is going to write information about deadlocks into your error log. I probably wouldn't be doing it this way anymore. This is the way to do it in SQL Server 6 and 7. Okay, there's a much better way for you to detect deadlocks in the latest version of the product. Don't enable 1204 and 1222 at the same time. I remember working for an insurance company, And they had a massive 3-node cluster, enterprise edition, massive database system. And I looked at one of the drives and there was literally like 100 megs left on that drive. It's like, what's going on? Why is the SQL Server binary LUN run out of space? It was a massive LUN. And I looked at the error logs, and the error logs were tens of gigabytes in size, because some guys from New Zealand, developers, it was being developed in New Zealand, were trying to troubleshoot the environment, so they turned on both 1204 and 1222. But they were generating so much deadlock information, the error logs just blew out from tens of megabytes to tens of gigabytes, and they almost brought that whole cluster down for the insurance company. Now, 1222 is sort of returning the same information as 1204, but in more of an XML type format. So you don't need to enable both. 1204 was around since version X of SQL Server, okay? 1222 was probably added in SQL Server 2005, probably, I can't even remember. So you might want to turn on 1222 as opposed to 1204, but don't turn on both because there's no need. However, as I said, I'll talk a little bit more about deadlock detection and a better way of doing that in a short while. This one's an interesting option here. Checksums are a good thing for backups. So when you're doing a backup, you want it to generate a checksum so that we know that the backup is good and can be restored, okay? Now what you can do is turn on trace flag 3023 so that all backups by default will have a checksum, okay? Now you can type in backup database with checksum, but the problem is you might be using the database maintenance wizard and that doesn't have a checkbox. Or you might be using some third-party vendor product which doesn't have that checkbox. So what you're doing in this particular case is telling SQL Server to always automatically enable checksums for backups, which is a good thing, okay? The other thing that you might want to take advantage of is 3226, and that is basically telling SQL Server not to write a successful backup message to the error log. So again, you might be doing a backup every 5 minutes of the transaction log, or every 10 minutes, every 15 minutes. So your error log is just going to be backup log successful, backup log successful, backup log successful, backup log successful. So then when you have a problem in SQL Server, you open up the error log and you have to wait 5 minutes until it reads that massive file, and then you're filtering and trying to find that information in there. So again, something that you might want to consider is turning on this particular option, which will prevent these successful messages being written to the error log themselves there. And the last one I won't talk about in a lot of detail, but it is very, very important that you understand what it does, because in 2016, it will be on by default. So it's going to potentially change the behavior of how SQL Server operates. So again, Microsoft are concerned about backward compatibility. They're never concerned about giving you improved performance when you upgrade from SQL Server X to Y. They want to ensure that your query will perform the same. If we improve performance, that's a bonus, but we want it to perform the same. So there's lots of bugs in the optimizer, but they don't want to enable them because your query performance might regress. So what they've done in the past is they had all these different optimizer flags. This fixes this problem, this fixes this problem, this fixes this problem, this fixes this problem. And then in SQL Server 2005 timeframe, they rolled all these optimizer fixes into one trace flag. Turn on 4199, and all these optimizer fixes are automatically turned on. So the problem is that, again, queries that used to work like this now work differently, which might be poor, so we don't want to change that. But the problem, of course, is that they're just putting more and more of these fixes into this particular trace flag. So they've decided in 2016 that when 2016 comes around, all of the optimizer fixes are going to be rolled into 2016 database compatibility level 130, okay? So again, with most of my customers, what we do is by default, we turn on these particular fixes because they're not interested in regressions. And if 80% of your queries are better off and 20% are worse, then we might as well just fix those 20%. But please read this particular trace flag. Please make sure you understand how it works and think about whether you should be enabling it now so that when you upgrade to 2016, you're sort of familiar with it, it's working for you, those sorts of things. So that's in books online as well. So again, think about deploying these trace flags into that standard operating environment of SQL Server, getting some benefits. So this is talking a little bit about deadlocks. As I said, you can turn on these particular trace flags, but they're going to write information to the error log. A much better way of detecting deadlocks is to use extended events. So what you can quite easily do in SQL Server is set up extended events to detect a deadlock. They generate a deadlock graph and store it in a database or wherever you want. Even better, whenever there's a deadlock detected, grab the deadlock graph, email it to the developers. it's a great way to getting deadlocks solved. Okay, if they're getting 10,000 emails per day of deadlock, 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 you'd be surprised how quickly developers all of a sudden are interested in this. So it's really, really quite easy to do. So as I said, quite easy for you to set up extended events, to write to a table somewhere. Alternatively, send it via XP_send mail or whatever it is these days, okay? So take advantage of this. Have a look at doing this instead of using the trace flags, which are writing to an error log file that nobody ever reads, okay? Let's talk a little bit about manageability. Okay, so again, some of this we've already covered. So backup compression, as I said, as I pointed out, released in SQL Server 2008, only in Enterprise Edition. In Standard Edition of 2008 R2, we introduced that into Standard Edition, So again, take advantage of that. So it can be controlled at the backup statement, or alternatively, you can set it as a server default. So take advantage of that. This is talking a little bit more about these particular trace flags with backup checksums there. So again, I've just given you some more information about that. So again, you might have an environment where you have hundreds of database backup scripts. And who wants to sit there and say, I need to change the script from backup database X to B to backup database with checksum to B? Okay, so what you can do, as you can see, you don't have to rewrite all of your existing backup scripts, maintenance plans, other utilities. You just turn on this particular trace flag and all of your backups by default will have checksums enabled. Okay, notice in SQL Server 2014, there's actually a backup checksum default. Okay, so you can take advantage of that instead. And that's, as I said, read the README files that come with the latest version of SQL. Have a look at the new features. Have a look at the new configuration options. You might define a new configuration option as a default for your SQL Server SOE. Okay, so that's all I wanted to say there. Let's talk a little bit about high availability. And as I said, just be careful of automatically using availability groups because availability groups is the new great thing inside SQL Server. So there's definitely a use business case for availability groups versus failover clustering there. So make sure that you do it for the right reasons. I would extremely, extremely recommend that you implement a proof of concept. If you're buying new hardware or you're virtualizing, it's easy as well. Set up a new environment, grab your database, put it into this proof of concept with availability groups, and then do some load testing with availability groups, without availability groups and with availability groups, and see the difference in performance. Okay, because potentially it can impact performance. Okay, and I'll talk a little bit more about that later on. But there's no substitute for doing load testing in an environment which represents a proof of concept for your database application. So definitely do that. So with failover clustering, I just wanted to say be careful of applying old knowledge to the latest version of clustering because the old knowledge is completely wrong and completely not what you should be doing with the latest version of Windows Server and failover clustering there. So it has substantially changed in in Windows 2012 R2. We've got different quorum types, we've got a file share witness, we have something called dynamic quorum, last man standing. The network configuration is completely different. We now have NIC teaming as well. So remember in the old days you had to set up a private network, you set up a public network. One had cluster traffic, one had cluster and network traffic. That is the wrong way of doing things. Okay, now, your cluster will be less available as a result of that. So all those old knowledge base articles are completely inappropriate for for Windows 2012 going forward. We also now support SMB3, RDMA, so there's all sorts of goodness happening there. So please make sure you reevaluate and understand how to deploy clustering inside the later versions of Windows. So here's an example of this classic configuration. We have two separate networks. This is not the default installation. They knew clustering for the last 10 years. They set up a new cluster on SQL Server 2014, Windows Server 2012 R2, and they used the old configuration pattern there. So notice a couple of things here. They've got two separate networks, one for cluster-only traffic, one for public, I think it was. No, cluster and client traffic. These days, you wouldn't be recommended to do that. You would have both of them on cluster and public. It depends on what you're doing there. But make sure, as I said, this is maybe a bit of a mistake over here. One was dedicated to cluster, one was dedicated to client traffic, okay? This is what you should be doing. You should be having one dedicated to cluster, the other one cluster and public, okay? So you don't have the cluster traffic just on one. That's what I'm trying to get at. Noticed over here they had also IP6 disabled. Guess what? All clustering traffic is using IP6. So if you disable IP6, what's it doing? It's tunneling IP6 and IP4. So again, you wouldn't be recommended to disable IP6, but that's what people were doing back in the day. So notice over here, they've disabled IP6. The other thing that they did was install a file share witness because it sounded like a good idea. And again, with a file share witness, you have potentially less availability. If the right combination of things go down wrong, your cluster will not come up. Okay, so you are better off using a node majority node set or a shared disk. Okay, so that would be the last one that I would use, but it sounds like a good idea. And again, it depends on what you're trying to set up there. But as I said, be aware of the quorum, make sure your network is configured correctly, make sure IP6 is disabled, and you want to have cluster traffic on all nodes. You could potentially have NIC teaming set up. So have two NICs, set up one team, and then have just cluster and public on that. So not even have two networks because you've got redundancy at the NIC level there. Okay, and most servers these days come with 4-port NICs and those sorts of things. And that way you don't even have to worry about different subnets and things like that. Okay, have 4 NICs in a team, put it onto the one network, and then we have cluster and network traffic across that particular NIC team. That's what I would be doing these days. Now let's talk a little bit about availability groups. So with availability groups really shine where you have multiple replicas of availability groups. So I have one customer in Sydney where we have 3 servers sitting in the city office and 1 server sitting in the Parramatta office. So we have 2 servers inside Sydney, which are the failover pair. We have a 3rd server, which is used by the analytics team. So in the past, they were using SAS and still do, and that's putting a load on the OLTP system, which 1,000 people are using in a call center. So you don't want your analytics and your DSS and your OLAP reports hitting the same server as the main call center OLTP environment. So what we've done is we've taken advantage of availability groups and the scale-out architecture so that OLTP activity is on one server, it's using CPU and RAM for that. Then we've got another server, and that's where all the analysis is done in real time. So that's where SAS is running, that's where the OLAP query is running, that's where the large DSS scans are running over there. So again, we're not impacting each other. Then we have a 3rd server in Sydney for failover, and then we have another one in Parramatta for DR in that particular case there. Okay, that's where availability groups really shine, where you start to do something like this. Okay, so you're starting to scale out your solution and use multiple replicas there. If you're using it just for high availability, yeah, possibly there's a case there, but clustering will give you that in any case there. The problem with availability groups is there's a few problems potentially. Number one, all your databases must be in full recovery model. Okay, now you might have something like a SharePoint environment which has the search database, and the transaction log of that just grows and grows and grows. So typically you have it set in simple recovery model, but you can't in this particular case because with availability groups they all have to be in full recovery model. So with failover clustering, the good thing is that the databases can be in simple, bulk logged, or full. We don't particularly care. The other thing potentially is that availability groups can impact performance, and that's why I was saying do a POC and do some load testing of your particular solution if you can. So I've got some slides coming up on that in a further discussion there. The other thing with availability groups, which they still won't fix in 2016, unfortunately, is that job management is a nightmare compared to clustering. Because with job management, you have to tell SQL Server somehow the job has to be scheduled on all the nodes potentially, but you have to run it only on the active node. And that's not easily done. There's not a checkbox that says just do backups on the primary or just run this particular ETL job or business process on the primary. Because the problem is you have a primary replica over here. If you fail over to, let's say, this one over here, then you have to get the jobs to run there and no longer run over here. So therein lies your problem. So it's not a simple exercise, it can be potentially quite complex. It's not difficult, but if you don't have that operational maturity that I talked about, then maybe availability groups aren't for you, and failover clustering is more than appropriate. You know, some people from Microsoft saying, oh, availability groups are going to take over clustering. That is completely wrong. There is a use and a business case for using one versus the other, okay? They are complementary. One is not trying to kill off the other, okay? Yes?
In the Sydney example you gave, what sort of node majority are you using?
Yeah, it was node majority set. So no, there were 3 nodes.
Yeah.
that have a vote in Sydney, and the Parramatta has no vote.
Has no vote. You
Yeah,
haven't given that.
that's right. And that's the other thing that you should do as well with failover clustering availability groups. Make sure the quorum is set up correctly. Okay, so sometimes when you install the product, it doesn't know that the Parramatta one's across a WAN link and that's potentially unreliable or slow, so it'll still give it a vote. So you take it out of the vote, yes.
So in this case, if the city one goes down, you'd force the quorum on the Parramatta.
Yeah, if everything goes down in Sydney, yes. But we have 3 nodes in Sydney, so we don't need a file share or anything else. So we already have 3. So that was, you need an odd number. Okay, ideally. Okay. So this is what I'm talking about in terms of availability group overhead. Okay, so as I said, just be careful. Do a POC, test your environment, see if you're going to get worse performance. You might not. But again, the importance is to do a POC. So this is the database that I was talking about. As you can see, it's a 2 terabyte OLTP database coupled with a 6 terabyte document store. Existing solution was on SQL Server 2008 R2, failover clustering on traditional SANs. The new solution was SQL Server 2014, the 3 nodes in Sydney, 1 in Parramatta with local PCIe SSDs, so no shared storage. And in our particular case, we have this batch process which runs at the end of the day and it runs at the end of the week. Now, 5 years ago or 3 years ago, when we upgraded them to 2008 R2, that process was taking 20 minutes at the end of each day and maybe 2 hours on the weekends. Fast forward, the business has grown, the data has grown, the processes are now taking 2 hours nightly and maybe up to 12 hours on the weekend. So time to refresh the hardware, upgrade to the next version of SQL Server. We want to use availability groups because we want to offload SAS from the OLTP environment. But here's the problem. Over here you can see labeled FCI, that's the failover cluster instance. You can see that now, in this particular year, the daily overnight rebuild process takes 102 minutes on average, 138 minutes, maximum minimum of 80 minutes. And this is the important thing that I did. We bought the new Dell R720s, we bought the local PCI SSDs, we migrated the database from the failover cluster to SQL Server 2014 with no availability groups. And as you can see, the minimum is 29, the maximum is 74, and the average is 40. We then implemented availability groups with a failover partner because we need to have that. And you can see over here, now the minimum is 70 minutes, the average is 72, and 84 minutes as an average. Maximum, sorry. So that's the overhead of availability groups there, as you can see. We then added a synchronous partner, and you can see it hasn't substantially changed things, so 81, 81, and 68 in this particular case here. On this particular half, on the right-hand side, we have the weekly overnight. So this runs on the weekend on Saturday midnight. So you can see on the old hardware on SQL Server 2008, we're taking up to 522 minutes as an average, 634 as a minimum, so that's over 10 hours, etc., etc. If my math is bad, and I don't think that is that, but never mind. So you can see again with no availability groups, that's down to 212 minutes or 227 as an average. And again, you can see with the introduction of availability groups, that's doubled the time there. Now again, the important thing is to find this out before you go live as opposed to roll an upgrade into 2014 and then find this out. And it's so easy for you to do something like this. Now in this particular case and in other cases, most of the time the problem is application and the way the application code is written and how that works with availability groups, okay? Having said that, Microsoft in SQL Server 2016 are setting themselves a benchmark of 95%. So what they're saying is, we want to have the same performance as no AGs up to 95% in 2016. So they've gone back into the code of availability groups and looked at the different threads, what they're doing, how they work, what they run, what triggers what, etc. And they're re-architecting that. And as of 2 weeks ago, they've said, look, we've met that 95% bar. So again, the overhead should now be 5% of having no availability groups. So that's a big feature, if you like, internally inside the release of SQL Server 2016 there. Okay, so they should do that. Now, what you might be able to take advantage of in 2014 is taking advantage of delayed durability. So with the way the availability groups work is, you basically are writing to the transaction log, and as you're writing to the transaction log, you're transmitting the buffer across the network to the other replicas. Now, what triggers the sending of that buffer? One of two things. You either get a commit transaction or you'll fill the buffer, which is 60K in size. So what's obviously more efficient? Wait till the 60K gets full, then transmit. 60K full, transmit. What's inefficient? Insert tran, commit, insert tran, commit. So small transactions, because whenever you do a commit tran, you're sending that straight away. It's the same thing between copying a large file that you've pirated off the internet onto your USB versus copying a lot of photos onto your USB, which take a long time because you need to open handle, write, close handle, open, write, so etc. So the idea here is you have this option inside SQL Server 2014, which allows you to say, don't send when we commit the transaction, wait until we fill the buffer, then transmit. So in our particular case, we found that that improved things by 20%. The problem, of course, is that potentially the system could crash before we send that 60K buffer. Okay, so again, be aware of the implications. So you can see, not hardening the logs effectively before the commit on the replica, potentially very useful, but be aware of the implications. And in our particular case, it wasn't a problem because we do a backup before we run these batch processes. So again, cost-benefit analysis for you. But this is where, as I said, you might get some wins with 2014 and availability groups as well. So let's talk a little bit about databases and speed things up a little bit. So again, just a couple of things to think about. Database files are just getting larger, okay? And again, I tend to see 5 minutes. We're in trouble. Okay, we might go a little bit over. So databases are only getting larger, and what I see people doing is just one database file. So one massive database file that keeps getting larger and larger and larger. So I think, again, when you upgrade SQL Server, take advantage of an opportunity of refactoring that. So let's talk a little bit about that. So again, what I'm really trying to do is get you to take advantage of file groups. So instead of having one massive 2 terabyte file, which is difficult to move, etc., this is what I'm doing with customers. I'm creating different files, putting in different file groups, and then putting different important tables or not important tables into different files there. So you can see that in our particular case, we've got an important table, which is the entry table, okay? That's 99 gigabytes in size. But I've put all the indexes on the entry table onto a separate file group, okay? So I've done that. We also have some auditing tables, not that important, so I've separated them out. So now I can see from a business level what data is growing, how quickly, how much, etc. The other thing as well that I can do potentially is take advantage of this particular DMV to see where we're writing most of the time, because that then allows me to fine-tune the storage subsystem in the future. So we might potentially, auditing isn't that important, put that onto slower storage, put some of the more important tables onto faster storage and those sorts of things. But if you start to separate your tables and indexes onto different files via file groups, you can start to do much better analyses like that. And again, it also gives me the flexibility of moving things around. Because if I start to run out of space on my local PCI SSD, I can move one of the files onto another drive or something like that. Whereas if I have one massive 2 terabyte file, I can't move that around. So I'm giving myself flexibility in the future, and it also gives me some optimization opportunities as well. So this is just talking about database compression. So we've talked a little bit about this. Compression, as I said, will potentially have some CPU overhead on inserts, updates, and deletes, but it should impact your query performance positively. So in this particular case, with this particular customer, we implemented page compression in SQL Server 2005. And you can see I sort of had a look at it before we upgraded to 2014. So the current database space is roughly 60 gigabytes, but if we had it uncompressed, it would be over 100 gigabytes. So we've still got a 40% saving, okay? And as I said, if I scan this particular table and load it into memory, it's 60 gig on disk, it takes up 60 gigs of RAM as well, okay? So we've got a good win in this particular case. And again, backups are improved, query performance is improved in this particular case here. So again, take advantage of this transparent technology. You'll get some really good wins with this. What you need to do is run some tools on the stored procedures which give you an estimate of the performance gain. And if it's around 60% of the size of the table, that would be my threshold. Implement it, as I said, some good wins. This is showing you an example where for one particular customer, they had a table which was over 100 gigabytes in size. And they're thinking that represents 6 months of growth. So we can't keep track of 10 years worth of data. We're going to have to start to archive soon. Okay, so we did a proof of concept, and hopefully we'll go live soon, where again you can see we've got this file with no compression, which is 115 gigabytes, let's say. We turned on page compression, went down to 50 gigabytes. We went down to clustered column store, 4.5 gigabytes. The business then said on this proof of concept, reports, a number of reports that took 2.5 hours to run are running under less than 30 minutes. And they don't have to now think about archiving the data, because now what was growing at 100 gig per 6 months is growing by 4 gigs per month potentially. That's changing the business. Yes, positive. Sorry? I'd have to notice the date. my memory is a bit. Let me think about it. I'll take it offline. No, it was not that wide, although it was wide. It was billions of records. Billions of records. I can tell you who the person was later on. I'll give you an idea of it. Yes?
Compression could be turned on a live system? Or
Yes.
Yeah, okay.
Yeah.
So it compresses it while the data's still being accessed?
Yeah, so you effectively rebuild the indexes, and that can be an online operation, and that's how you get it there. Okay? Okay, so this is talking about column store indexes. I'm not going to go through this in a lot of detail, so again, we're running out of time. So again, this is just showing you how we're storing things at a column level instead of storing things in a row level there. And this is just talking a bit about 2014, where, as I said, we introduced updatable clustered column store. So instead of having a table with 20 non-clustered indexes, you can have one clustered column store, and that's all you need. So you get rid of all those data warehouse scenarios where one fact table, multiple non-clustered indexes, which might be 5 times the size of the table collectively. So you can get some really phenomenal wins with this. It's designed for what? Data warehousing scenarios. That's what it's designed for. But think creatively. So again, some benefits over earlier versions of SQL 2012. They introduced also a new archival compression, which will give you slightly better compression, but it will take up more CPU cycles in that particular case there. Clustered column stores really work well where you have large queries running which take advantage of batch operation, because SQL Server otherwise is a row-by-row processing engine. Fetch row, process, fetch row, process, fetch row, process. If you take advantage of clustered column store indexes or column store indexes, and you write queries in a particular way, you can get a massive improvement in performance because you go to batch execution mode. So you can process a batch at a time as opposed to row by row processing. So that's your goal, if you like, of SQL Server with column store indexing. So this is again an example where we've got clustered column store indexes and archival clustered column store indexes. So again, you can see again, 115 there's a number of records, 218 million records in this particular case, 115 gigabytes, clustered column store down to 4.4 gigabytes, archival down to 3. So the thing I wanted to point out with column store indexes, think creatively. What are they designed for? Data warehouse scenarios. How many people here have auditing tables? Do you ever read them? No. You have to audit for compliance reasons. You hardly ever query them. You hardly ever need them. So what you can do potentially is take advantage of auditing. Implement on your audit tables. So again, reduce it from 134 gigabytes down to 14 gigabytes. Okay? We hardly ever query them, but the idea here is we've met our compliance reasons there. And you can see over here, here's the overhead. So again, you can see that it takes a bit longer, 2 minutes to run on the first run with clustered column store versus non-clustered column stores. But the idea here is you hardly ever query them. You only need them when something happens inside your environment. So just quickly finishing up on refactoring opportunities, think about your technical debt. So start paying it off. So again, this is just a list of things to do. And the one that I want to concentrate is think about data types. So start paying off your technical debt. There are data types that are deprecated. There are better data types, etc. Think about release management. Think about moving things into the cloud. So here's just a list of the deprecated data types, and I just wanted to concentrate on text and image. Get rid of that. Think about starting to implement date or time as opposed to date time, or implementing date time too as well. Think about these better programming patterns as well. Paying particular attention to transactions and set transaction abort. 80% of the industry writes transactions incorrectly and they don't know it. Okay, so pay attention to that. And think about contained databases. So with future state, as I said, think about your database as a service and think about it being able to be moved between tiers, moved into the cloud, etc. there. So start to think of databases as a service that you provide, decouple databases from SQL Server instances. So if it becomes more important, move it from tier 2A to tier 1B, those sorts of things like that there. So you want agility between tiers. Start to document things so that you can upgrade more quickly as well. Okay, so that's the goals. I'm not going to spend too much time on this. How scary was that? So this is SQL Server 2016. What is that on the right-hand side? That's a monster. It's going to be a monster of a product. Look at all the legs that it has. It's going to be coming at you like a fast train, okay? Look at the number of eyes that it has. It has 9 eyes. It has 4 mouths. Look at the number of arms that it has there. Okay, that's my 4-year-old Marcus drew that. He's very excited, very proud of this. 2016 is going to be a monster of a release. And it's not just going to be about features. So stop thinking about features. There's going to be a lot more happening with 2016 and how Microsoft are going to go forward with that. So Microsoft are rethinking a whole bunch of stuff with how they release SQL Server, how it's going to be patched in the future, how you're going to get new functionality, etc., etc., etc. I was at Redmond 2 weeks ago. So it is, as I said, a fast train coming at you. And you can decide to get on this fast train, and the sooner you upgrade to 2016, the sooner you can start to take advantage of this new functionality. So there's lots and lots of features, and I've just cherry-picked a few of them. There's a lot more happening. But as I said, the way we're going to now manage, deploy, and run with SQL Server potential is going to be completely different from the last 2 decades. So again, highly encourage you to look at it seriously, think about some of these things that we've been discussing. And as I said, some of these things, you're getting benefits from upgrading by taking advantage of certain features, and some of them are totally, totally transparent. Okay? So with that in mind, I need to get off stage. Sorry for running a little bit over time. So as I said, with the deck, you can see at the very end of the deck, after the last slide, oh, they trimmed them. So, okay. At the end of the deck, I've got all the differences in different versions of SQL Server. So use that as reference. Otherwise, free to take questions. Obviously, we have to take it outside. Thank you very, very much for your time and patience. Sorry for going over, and all the best.